Hello, good morning, good evening, everybody. I'm Dr. Asavari Manvikar. I would like to welcome you all for CAR, Council for Ayurveda Research Global Webinar Research Series. Global Council for Ayurveda Research is an international non-profit organization based out of USA with its sister chapter in India by the name of Ayurvidya Anusandhan Abhiyan Foundation, AAAF. Our mission is to encourage, educate, and facilitate basic clinical and interdisciplinary research in Ayurveda. Our vision is to promote and establish Ayurveda as an evidence-based science globally. You can learn more about us at www.ayurvedaresearchusa.org. Please do consider joining us as a member, which will bring you access to all of our resources. And no nonprofit can operate and succeed without the volunteers. So consider joining us as a volunteer and we can place you in a variety of projects based on your skills and your interest. Once again, our website is www.ayurvedaresearchusa.org. Now let me introduce our platinum sponsor, Komal Herbs. It's a company based in Pennsylvania. It is focused on the concept of Ayurveda and the power of being healthy using herbals and natural products. Komal Herbals work hard to find premium ingredients for their herbal formulations. They also source herbs and spices that are sustainably and organically grown around the world. Now let me introduce our eminent speaker, Dr Ila Bhor Karandikar. She is BAMS, MD in Dravyaguna. She worked as an associate professor at College of Ayurveda and Research Center in Nigri. She has extensive experience, more than 19 years of experience with teaching. She has been guiding postgraduate students for last 14 years. She specializes in pure Ayurvedic Shodhan and Shaman treatment for various diseases, running pure Ayurveda clinic for more than 23 years. She specializes in identification of medicinal plants and cultivation of medicinal plants and creation of unique medicinal plants gardens. She has extensive research experience. 8 research papers she has published in various journals. More than 10 papers presented in various national and state level workshops and conferences. She has contributed to many projects, created herbal garden with more than 300 species, with rare and endangered medicinal plants in Konkan, at Rishi Herbal Garden, and conducting study tours for Ayurveda students to give live demonstration of medicinal plants. She has developed 2 medicinal plants garden with plantation of rare and endangered listed plants in the Working Institute at PDEA's College of Ayurveda and Research Center at Nigri. She has conducted many trials of cultivation of medicinal plants for more than 15 years with organic and Vriksha Ayurveda method. She has done various projects with postgraduate students on the cultivation techniques mentioned in Vriksha Ayurveda and ancient science of plants. She is working on 2 literary studies. She has completed 2 literary studies and 2 ongoing literary projects with MD Dravyaguna students as a guide. She has done extensive collection of photographs for identification of herbs in their habitat with various field visits all over the India. She has won various prizes for study and cultural activities in the academic career. She has delivered many lectures on Ayurveda and medicinal plants. She has published various articles on Ayurveda and presented various research papers in the seminars. She has been running her own Ayurvedic pharmacy, Rishi, her herbocare, and trade of raw material, namely Rishi herbs. She has worked with International Academy of Ayurveda for Dravyaguna teaching in Israel Ayurveda Academy students. She has learned many different ancient scripts like Sharada, Nevari, Old Nagari. And currently she is working with editing unpublished Ayurveda manuscripts with collaboration with other work Ayurveda manuscripts with Siddham Institute at Varanasi. She has published many books. Some of those are research methodology and biostatistics for Ayurvedic students. Ayurveda Amrut Hindi book. And she has also created a mobile app, Ayurveda Amrut. So I'm very happy to have you, and it will be really nice for all our attendees to learn about your extensive experience in Dravyaguna. I welcome you, Dr. Ila Bhor.
Thank you, Vasavari. I am very much thankful to you for giving me this opportunity to present my work in front of you, and also thankful to CGAR also for giving me chance to present my work. So now can I start?
Yes, please.
Yes. So again, I have to share my screen, or
you need to share.
Yeah. Is it okay?
Yes, it looks great.
So, my today's topic of presentation is researches conducted in Dravyaguna department. So, I, Vaidya Ila Bhor, I am associate professor in the department of Dravyaguna in PDES College of Ayurveda and Research Center, Nigdi, Pune in Maharashtra state, India. So, the content of my presentation will be, first, I will show you the various research areas in Dravyaguna field or in herbology study with which we can find out our areas of interest on which we can work. So, and later on, some examples of researches conducted by me with assistance of my MD students and with basic information and proofs of my work, and some ongoing researches also. So now we will see first what are the research areas in Dravyaguna if we want to research or we want to collect data. So there are many unpublished literary manuscripts. So or some published, but work is not critically edited of some manuscripts, or not compiled in terms of Dravyaguna. So first, so from time to time, considerations of drugs are changed in Ayurveda since ancient Samhita period to modern period. So addition of exotic drugs in Ayurveda, Ayurveda lexicons with their properties, periodical substitutions instead of original drugs due to non-availability, or with similar Rasapanchaka properties is seen nowadays. So trading of drugs and addition of different varieties time to time, these facts should be explored through the literary study. So different clinical aspects through drugs from different texts can be understood through this study. So we can study with different text if there are some different preparations or different clinical aspects are suggested. So we can do comparative study based on the literary study. So with the literary study is also one type of fundamental work which we have to do, that exactly what is expected in Ayurveda regarding the herbs. So literary study is the base of the study, we can say. Then we can do clinical study. So in clinical study, retrospective clinical trials of drugs with different conditions of diseases can be done with clinical study. Data of some unexplored Dravya yogas, that is formulations, is possible to generate with this. Or we can do prospective study with different combinations or action of extra pharmacopoeia drugs is possible to search. Then comparative clinical trials of different drugs can be possible, and better efficacy of drug part or drug dosage form with specific conditional use is possible with this. So we can do many type of work, comparative work or single drug, single exploratory clinical trial we can do, or single blind or double blind clinical control trial we can do. So there are so many ways or so many study designs of clinical trials. So the another area of research in Dravyaguna is pharmacological study. So experimental study of drugs with different pharmacological models and specific study design can be conducted and data generated. It is the important step in clinical research, as you all know. So creation of different drug models in Ayurvedic terms of conditions is the challenge. So we have to develop as per Ayurveda needed base model. So nowadays we are using the ready pharmacological model or animal model which is ready, and we fit our study design into it. But it is very challenging to create a new model as per the demand of that particular research. So this is the area. Then another area is analytical study. So analytical data of drug is generated with this study. Comparative analysis of different market samples of the same drug with original one is possible, and adulteration and current trends can be searched. So with the help of quantitative and qualitative analysis of drugs, active essential ingredients or active principles of drugs can be searched. Analysis of different species and comparative study with this is possible. Then analytical parameters should be matched with API standard, that is in Ayurvedic Pharmacopoeia of India in India is essential to consider a standard herbal raw material. So we can do various types of analytical study. Then other type of experimental studies are the studies can be done on standard cultivation practices of medicinal plants or some modified techniques adopted for better yield. Then good harvesting practices, standard collection practices according to season and desha or land concept mentioned in Ayurveda. So cultivation practices as per Vrukshayurveda techniques are very much needed, which will be more similar, seems to be biotechnological aspect regarding cultivation. So Vrukshayurveda is very ancient science in which we can say the study or science of plant, with the help of which we can do the better work nowadays. So and again the tissue culture technique for mass propagation and cultivation of medicinal plants is going nowadays, and it is very essential also. Comparative studies of Vrukshayurveda techniques versus tissue culture techniques can also be taken. I have done some of in these areas, and which I will show you later. In our department, we have done some research work on some fruits. The examples of some are critical study of Madanapala Nigantu that is Phalavarga, that is classification of fruits, and its revalidation of Sevaphala properties mentioned by Madan Palak with apple fruit in healthy volunteers. I will show you the details of it. Then comparative study of qualitative and quantitative evaluation of patol, that is Trichosanthus cucumerina drug, cultivated by Vriksha Ayurveda and conventional practice. Then my colleague has done comparative study of qualitative and quantitative evaluation of alambu, that is alabu, cultivated by Vriksha Ayurveda and conventional practice. Then comparative pharmacognostical literary study of classical Badara varieties, that is Ziziphus, Jujuba varieties. So like that, these are the research areas. And now we will move towards the actual, some examples of the studies which I have done. So the first one, I will show you the one clinical study which I have conducted, a single drug trial, that is the study of efficacy of mundi or Gorak mundi, that is Sphiranthus indicus herb, on obesity, that is Thaulya. So the study design was, I have taken two groups, that is in group A, Gorakhmundi powder 10 grams per day in 2 divided doses with warm water in empty stomach for 60 days. I have given, and in group B was the placebo group. So total 40 patients were taken for the trial. And during pilot study, it was observed that Gorak Mundi is the drug which is very Tikshna, Ushna, which is very potent drug. So the 10-gram dose was not palatable for the day. So it was reduced to 6 gram per day, and the study was conducted further. Then some observations and results I have found that Gorakhmundi showed statistically highly significant effect on symptoms like body heaviness, that is Anga Gaurav, then Atikshuddha, polyphagia, then Ati Nidra, that is excessive sleep, Daurbalya, weakness, on Malabaddhata, that is on constipation, and loss of energy, in body ache, and dyspnea, and also highly significant relief on body weight, BMI, tricep and waist and hip circumference also. So, but I have observed no significant relief on serum cholesterol and serum triglyceride levels in 60 days trial. So, this is the finding. And the Gorakhmundi showed better efficacy on menopausal symptoms in obese women. So this was very much challenging, and one clinical trial I showed to you. Then the another trial of cultivation. So cultivation of Manjishta plants. Manjishta, that is Rubia cordifolia, is the very rare and endangered category plant, comes in rare and endangered category. And in Ayurveda, we use very extensively Manjishta roots are used. So the propagation and cultivation methods or propagation techniques of Manjishta, uh, the research on that is very essential. So comparative experimental study for survival of Manjishta plant cultivated by tissue culture technique with Vrukshayurveda method with cow dung application by using nodal segment. This study is done by Dr. Priyanka Chavan and me. So Manjishta can be propagated both by seeds as well as vegetative means. So seed propagation, the germination rate is generally poor and viability is 3 months only. And the mother plant available in institute showed less fruiting as compared to flowering in my institute. So for vegetative propagation, tillers, stems, rootlets from the mature plants can be separated easily and planted individually. As roots of Manjishta goes too deep in the soil, it is difficult to get roots for the cultivation. Also, the use of roots is likely to destroy the entire plant. So considering the facts, it is more convenient and feasible to use stem instead of seeds and root. So we have taken Manjishta stem. And the reference we have used, that is Surapala's Vrukshayurved. This is the one of the best ancient literatures which is available and which deals with the science of plant life. By using the reference of Surapala's Vrukshayurveda, method of stem propagation, stem cuttings was selected for the study. In Vrukshayurveda, two general methods have mentioned as Kadali, that is banana pulp paste application, and Gomay, that is cow dung application on stem for propagation of any plant through stem. Out of which method of cow dung application has been selected for Manjistha cultivation, as parallel study was processed by the method of Kadali pulp. So my colleague has chosen the Kadali pulp, and my student has chosen the cow dung method. To study the effectiveness of Vrukshayurved method, tissue culture technique was taken as proven method. Aim of this study was to conserve and increase the availability of Manjistha on large scale. Hence, both methods of cultivation as Vrukshayurveda and tissue culture were selected. This comparative experimental study was done in three groups, as Group A Vrukshayurveda, Group B Tissue Culture, and Group C Conventional. In the synopsis, only two groups were mentioned, but when actual study was started, Group C, that is conventional, added as comparative control group. So Vrukshayurveda and conventional method of propagation was not conducted before October 2019 due to heavy rain and lack of intense sunlight to dry cow dung. So the study was conducted from the month of November 2019 up to July 2020. Pilot study was done in the month of August and December 2018. This study shows better results. With this reference, month of October and November 2019 was selected for conventional and Vrukshayurved method. So method of stem propagation as mentioned in Surapala's Vrukshayurved have described in chapter of material and methodology. So 18 angul, that is 30 centimeter long stems were collected from the institutional herbal garden. All process of propagation was conducted as per methodology and details are noted. According to guide, red soil was used instead of black soil for planting the stems. Then 10 centimeter of Manjistha stems were selected instead of 30 centimeters, as the Manjistha is a climber. So the fragile stems were broken after application of cow dung. So all the plastic bags were, so we have chosen 10 centimeter of Manjistha stem instead of 30 centimeter. And all the plastic bags were kept in the shade after planting. As in group A, sprouting was not observed till the end of first week of propagation. Cow dung was manually removed in second week to see the sprouting. In group C, first sprouting was observed in first week of propagation with the reference of observation tables. It is observed that result for leaf count and height is significant in group A, that is in Vrukshayurved group, than the group B, that is tissue culture group. It is observed that survival rate is more in group A than B, which may be due to application of cow dung and plant growth enhancing property of cow dung. So here we can see the group A collection of stems, Manjistha stems, and the application of cow dung. How we have created this. Then we will see the propagation with tissue culture method. So group B was the tissue culture was conducted in two separate labs. We have to conduct it in two separate labs, as in first lab there was a bacterial and fungal contaminations every time with proven method. Hence the procedure was repeated in second lab with some modifications in process of surface sterilization and media preparation. So we will see the protocol first, that is in the research conducted in first lab. We have given a base or a standard protocol of a published paper. With this, we have tried in as protocol 1, that is from January 19 to February 20, the study was conducted in MS plus TDZ and plus PVP liquid medium. And in that we developed 1 to 2 shoots we could see within 2 weeks. After 2 weeks, they all contaminated with bacteria and fungus. This experimental proven method of tissue culture was repeated for 9 times, 2 times in MS solid and 7 times in MS plus TDZ. So MS plain media developed one shoot which was transferred for better rooting in MS plus BAP plus IAA solid media after 2 weeks. But this one was also getting contaminated on second day with fungus. So this shoot was directly transferred into soil instead of keeping rooting media. This shoot was not survived after hardening. Contaminations are maybe due to recalcitrant of Manjishra stain, recalcitrant property of the Manjishra stain, and maybe because of instrumental or lab hygiene. So we have followed or we have modified slightly. In second lab, protocol 2 was as such that shoots developed from nodal segments were inoculated in solid medium, whereas one shoot and maximum shoots of 1 to 2 developed on MS plus TDZ solid plus MS plus TDZ plus 1.1% PVP liquid medium, and MS plus KBI plus BAP plus IBA. So root induction was achieved within 1 to 3 weeks, and 2 to 3 roots developed in this medium. MS plus KBI developed 1 to 2 roots. This method showed better results within 5 months. Out of inoculated stems, 3 stems showed sprouting, which are survived till date. It is observed that group B showed better result within 5 months with maximum number of leaves and maximum height with as compared to group A and C, which is might be because of hormonal treatment. So if we see the qualitative assessment, sprouting of Manjishra stems were observed in group B and in group C in first week. In group A, second week of propagation, the sprouting started. More growth of leaves were noted in group B and A than group C. In group B, protocol 1 were showed bacterial and fungal contamination, and so there is no any insect or contamination in group A and group C. And in as per quantitative assessment, maximum height, maximum number of leaves of Manjishra plants were observed in group B and group A than group C. That is the conventional. There was no treatment for the group C. So group C were showed very less growth of plants. Thickness of root of group A, that is Vrukshayurved, and group B noted as similar, but the length of roots were longer in group A, that is in Vrukshayurved, than group B and C. Group C showed very thin roots. The duration of study was for the group C is 5 months and 10 months for the group A and C. So here we can see the growth of Manjishra leaves in 3 groups. We will see the next slide, the comparative. So when we compared the group A, B and C, so the number of leaves, the interpretation was the mean number of leaves is maximum in group B, followed by group A and then group C. So we can see in tissue culture group, the maximum number of leaves, we can see the maximum. So now in case of average increase in size of Manjishra plants in 3 groups. So average height when we compared in 3 groups, then the interpretation was the mean height of plant is maximum in group B, which is followed by group A and then group C. So in 3 groups, the height increases, but the maximum height seen in group B, that is in tissue culture group. So in the another criteria of survival of Manjishra plants. So in group A, Vrukshayurveda, 15 number of stems were propagated and 15 plants were survived, that is 100%. In tissue culture group, 8 stems propagated and the In 8 stems inoculated, then 3 survived, and total plants 3, and 100% survival rate is in tissue culture. But out of 8, 3 generated. So, and in conventional method, 15 stems propagated. Out of this, only 6 survives. That is 42% is the survival rate in group C. When we compared the thickness and length of roots, so in Brookshire Veda, that is group A method, the thickness was seen in 6 millimeter and 20 centimeter. And in tissue culture group, 6 millimeter and 18 centimeter, that is near to same, the both groups. And in conventional method, 4 millimeter and 10 centimeter, 4 millimeter thickness and 10 centimeter height we can see. So here we can see the comparative root growth. This is group A is Brookshire Veda, group B is tissue culture, and C is conventional. That is no treatment at all for group C. Here we can see the Manjistha propagation through stem cuttings, how the shoots started and how plants survived, sprouting and growth of plant. So in group A, transfer of bags. So then we transferred it, and survival is 100%, and growth is also very good. And we can see the in group B, that is the protocol 1, which was unsuccessful, which was we can see the sprouting, then contamination also we can see, contamination, inoculation of plain MS media. So protocol 1 was the failure, and so sprouting was seen, then transferred, and we directly transferred to soil, but we have got no results for protocol 1. So we have followed protocol 2. So inoculation in MS solid plus BAP. So the sprouting we can see here, and the survival of plants are also very good. So protocol 2 was the successful method, and this is the conventional method, that is group C, sprouting and the survival, and growth was comparatively less, but sprouting and survived, plants that survived. So this is the transfer and the survived plants. So cost, when we see the cost effective assessment, the cost effectiveness of Brookshire method refers to rate soil, then seed treatment, nursery bags, pots. For conventional method, there are no any cost effectiveness. Cost effectiveness of tissue culture technology lies in vitro techniques used, such as simplified medium composition, reduced time of organogenesis like shooting, rooting, etc., rising of plantlets, outside laboratory conditions, such as simpler but sustainable hardening protocol and duration of acclimatization in the shade net or greenhouse. The most important thing is percent survival or stand of tissue cultured plants on field. These criteria should be at least comparable or superior quality to other techniques used for propagation. So cost-effective technology referred to total duration required for plantlet generation, minimum, then more effective total quantity of input of media constituents, including agar, hormones, required per unit, and total electricity consumption for duration of experiments, for running equipment like autoclave, laminar, lights, AC for growth room chicken. The cost rises with high frequency of contamination of growth media, number of times repeating the experiments, recurring expenditure like chemical constituents of growth media. So we compare this in Brookshire Veda method, it is slightly cheaper. So Manjistha is comparatively good in Brookshire Veda and tissue culture than conventional method. On the basis of statistical analysis, group B tissue culture was seen more significant than group A, as uh, in protocol 2, that is in second lab, in within 3 months, the results what we achieved were the within 3 months. And in Brookshire Ved method, the results we have seen in around 8 to 9 months. So this was the difference between group A and group B. And the group C conventional method was cost effective, but the less growth we saw. So in group B, tissue culture showed rapid and fast growth with alterations in proven protocols. Group B showed high cost effective than group A in our case, not each time. Every time it may not be possible. So now we will move the next research work, that is analytical research work. That is a comparative pharmacognostical and phytochemical analysis of root bark and stem bark of two species of Rohitaka plant. Two plants are taken in the name of Rohitaka as per CCRS, that is Tecomella undulata and Aphanomyxis polystachya. This work was done by Dr. Shivani Sonar under my guidance. So we can see the two plants here. And the primary objective of this study was to compare root bark of Tecomella undulata with stem bark of Tecomella undulata on the basis of pharmacognostical and phytochemical properties. To compare root bark of Aphanomyxis with stem bark of Aphanomyxis. Then compare root bark of Tecomella undulata with root bark of Aphanomyxis. Then to compare stem bark of Tecomella undulata with stem bark of Aphanomyxis. So in market we can get the stem portions of Rohitaka. Most of the times Aphanomyxis stem we get in the market. But Tecomella root of Rohitaka references are there in Sharangdara and in some places in Ayurveda. So we have done this type of study design we have taken. So other objectives were to find out whether stem bark of Tecomella undulata can be used as substitute of root bark of Tecomella undulata on the basis of their phytoconstituents. To find out whether stem bark of Aphanomyxis can be used as substitute of root bark of Aphanomyxis. So here we can see the stem bark of Tecomella undulata and the root bark of Tecomella undulata on the left side. And in the right side, the stem bark of Aphanomyxis polystachya we collected from the feed and the root bark of Aphanomyxis polystachya. So two different field samples of Rohitaka. So in organoleptic study, only the difference we can see in case of Tecomella root was pale yellow. The inner surface of Tecomella root was pale yellow, and the taste of Tecomella stem was bitter and astringent. That is Tikta and Kashaya we have found. Then the texture, outer surface of Tecomella stem was rough with longitudinal irregular cracks. This is the only difference we have found. Otherwise, all the findings were almost same. Not much difference. In case of extractive values, water soluble extractive values among the samples Tecomella undulata, root bark has higher percentage of water soluble extractives. Also, root bark of both the species have a higher percentage of water soluble extractives than stem bark of both species, which means it has higher amount of tannins, sugars, plant acids, and mucilages. And in alcohol soluble extractives, among all four samples, Aphanomyxis root bark has higher percentage of water soluble extractives. And also root bark of both the species have higher percentage of water soluble extractives than the stem bark of both species, which means it has higher amount of tannins, resin, and alcohol. Microscopically, no significant difference was seen, except stem bark of Tecomella undulata shows presence of Ceratenchyma. No significant difference between root bark of both species microscopically found. Then in chromatographic study, ethanolic extract of stem bark and root bark of Tecomilla undulata shows one spot having same RF value. Methanolic extract of root bark of Tecomilla and root bark of Aphanemixis shows one spot having the same RF value. Spots having same RF value may contain same phytoconstituent. In fluorescence analysis, after reacting with the reagent, powder of stem bark and root bark of Tecomilla and Aphanemixis shows fluorescence. Ash values, root bark have greater value than stem bark in case of both species. Therefore, root bark may have more percentage of inorganic salts, minerals, and earthy matter. All samples have pH below 7, which means are acidic in nature. In phytochemical study, alkaloids, phenolic compounds, tannins, flavones, flavonoids, carbohydrates, reducing sugars, phytosterols, like such compounds were present in stem bark and root bark of Aphanemixis as well as Tecomilla. Amino acids and proteins are present only in stem bark of Tecomilla undulata. Gum and mucilages were absent only in root bark of Aphanemixis. Root bark of Aphanemixis and stem bark of Tecomilla show presence of steroids. Lignin was absent. As Kvatha Kalpana, that is decoction, in decoction mentioned in Ayurveda is homologous to water extract. Hence, phytoconstituents present in water extract might be present in Kvatha. So the conclusion, there is no significant difference in stem bark and root bark of Tecomilla undulata. Therefore, stem bark of Tecomilla undulata can be used as substitute of root bark of Tecomilla undulata on the basis of pharmacognostical and phytochemical analysis. But we have to again research the clinical trial on both the comparative clinical trial we have to do. There is no significant difference in stem bark and root bark of Aphanemixis. Therefore, stem bark of Aphanemixis polystachya can be used as substitute of root bark of Aphanemixis as on the basis of performed pharmacognostical and phytochemical analysis. There is no significant difference in stem bark of Tecomilla and stem bark of Aphanemixis. Therefore, stem bark of Aphanemixis polystachya can be used as substitute of stem bark of Tecomilla undulata. There is no significant difference in root bark of Tecomilla undulata and root bark of Aphanemixis. Therefore, root bark of Aphanemixis can be used as substitute of root bark of Tecomilla undulata. As usually we get the Aphanemixis stem bark in the market. So we have done these different analysis, and we have to do clinical trial, the comparative clinical trial. On the basis of that, we can conclude 100%. So the next research which I have conducted, that is another analytical work, a comparative pharmacognostical and physicochemical study of feed and market samples of patola leaves. That is Trichosanthus cucumerina. In patola, there are 2-3 species are used or we get in market. So commonly used species of Trichosanthus, patola, Trichosanthus dioica is the species name. The local name is parvala, which we use in as in food as vegetable. From in North India, it is very commonly used. Then Trichosanthus agvina, which is the patola or padaval, we say, and it is also used as vegetable. And Trichosanthus cucumerina species is the wild species and which is very bitter. So collection of field samples done from various regions of India, North India, South India, and Maharashtra. So North India, Varanasi coded as F, sample from South India coded as BF, then sample collected from Maharashtra coded as CF. So Pharmacognostical study sample, all three samples resembles with each other. In physicochemical study, foreign matter percentage, moisture percentage, total ash, elemental ash, extractive values, chromatographic studies were done. In chromatographic study, sample AF and AM are same as sample BF and BM, but sample CF and CM are not same because of variable in RF values. Sample CM is different from BF, BM and CF. So sample CM resembles same with sample AM, AF and AM pharmacognostically. But in from physicochemical study, it is very difficult to arrive some conclusion because variables in the present findings. So some synonyms of patola, that is Trichosanthus dioica, resembles to Trichosanthus cucumerina, which is a substitute of Trichosanthus dioica as per Bhavprakash Nigantu. Trichosanthus dioica and Trichosanthus equina are the cultivated species, but Trichosanthus cucumerina is wild variety. Taste of patola is tikta. Its fruit is sweet and used as vegetable, but taste of Trichosanthus cucumerina is totally tikta. In pharmacognostical and physicochemical study shows that chemical constituents in Trichosanthus dioica and cucumerina are nearly same. From the above observations, it is difficult to arrive definite conclusion regarding the identification of the variety of patola which are mentioned in various classics. However, Trichosanthus cucumerina can be taken as tikta patola due to bitter taste of all parts of the plant, which can be used in medicine. And Trichosanthus dioica can be coated with swadu patola through fruit is sweet in taste. So the study was limited to analysis of patola leaves only, but patola panchanga, that is all patola panchanga in APSC Mumbai market is get adulterated with Karavellaka, that is bitter gourd panchanga is seen with the collected market samples. So both are bitter. So bitter gourd panchanga is adulterated in patola sample. So here the paper is published in as per the study comparative pharmacognostic and analytical study of patola field and market samples. The findings were same as I said earlier. So we will go further. Here the different species of patola. In left side we can see the Trichosanthus dioica, that is parvala. That is the fruit is used as a vegetable, regular food item in North India. Then the middle one is the Trichosanthus equina, which is very commonly used in Maharashtra in our region as a vegetable. That is Trichosanthus dioica, and the right one is the Trichosanthus cucumerina, which is the bitter, very bitter and the fruits are small in size. Here we cannot say all details of study. So we will move to the next research, that is experimental study for revalidation of saber. So I have taken the critical study of Madanapala Nigantu, that was the literary study Phalavarga of Madanapala Nigantu, and in that Phalavarga, Seva Phala is mentioned, which resembles with the Simbitica or Sinchitica fruit mentioned in Charak Samhita. Nowadays, we can compare that fruit with the apple fruit. So in healthy volunteers, the experimental rasa pariksha was conducted to determine the rasa test of the sevaphala. This study was done by Dr. Ashwini Amalwad and with my guidance. So Madanpal has introduced many new exotic fruits, that is kharbuza, aloo bukhar, amrutaphala, naspati, seva, peruka, etc. So the Madanpal Nigantu was very peculiar, and Peruka, Sevaphala, Amrutaphala, Aluka, Shilemani Kharjura, Saramla, then ela phala, kharbuja, rajamra, kapithapatri, kataka, and tuvar or tumbara. So there are so many uncommon fruits were mentioned first time in Madanpal Nigantu. So we can see these fruits mentioned by Madanpal Nigantu are the native of different countries. That is the fig, Anjir mentioned by Madanpala is native from Southwest Asia. Then guava, Peruca was native to Mexico and Central America. It is first time introduced by Madanpala as Peruca in India. Then Aruca, the exact identity is not known nowadays, but this was introduced from Western Asia, that is to Kabul to India. Then Karmaranga, it is believed that it may have originated from Sri Lanka, Indonesia, but has been cultivated in Indian subcontinent for hundreds of years from since 10th century. Then in case of Kharbuja, that is musk melon, is also native to northwestern countries. And then we will move further. In case of dates, Kharjura, native to Africa, Syria, Arabian Peninsula, and uh, the various types of Kharjura, that is dates types, are mentioned in Madanpala. Then in case of coconut, Narikel, native to Indonesia, has first introduced in South India since very ancient period. So since Charak Samhita period, Narikel is used. In case of Naspati, the pear is native to coastal and mildly temperate region of old Western Europe. Then orange, native to China or Cochin, China, later imported in India. Then pista also. Three unique, the trees are unique to Syria, introduced in Charak Savita, very ancient period. This pista also mentioned. So some native fruits, jujuba also, then almond, badam, then madhu karkati, lychee, that is ela phala is mentioned by Madanpal, and lavali phala, that is sikka acida, is mentioned in phala varga. So we will move to experimental study. After literary study of Madan phala varga, attempt is done to develop simple methodology for the assessment of rasa virya vipak for the ukta or anukta or leshokta dravyas, that is considering the seva phala of Madanpal Nigantu as apple fruit. So study includes literary work of Madanpal phala varga, then experimental study of rasa virya vipak of apple fruit, assessment of observations through questionnaire was done. So objectives were to compare literature about Madanpal Nigantu with other Nigantus, to revalidate properties mentioned about Sevafala by using apple fruit with specially designed experiments by questionnaire, to develop simple methodology for assessment of Rasa Virya Vipak on the basis of specially designed experiment and questionnaire. So the Sevafala, that is considered apple fruit, that is Malus sylvestris, which has having the Madanpal has mentioned the rasa of Sevafala is Madhura, Vipak is Madhura, and Virya is Shita. And it is of having Shita Virya Snigdha Guru Sara Gunas, and which is Bruhana Brusha Daha Shaman properties, and which is Kafahara and Pittahara, the action of doshas. Then trial design of healthy volunteers. The experimental drug was apple. Line of work, daily apples were given to 25 healthy volunteers after taking informed consent. Those two apples approximate weight 250 grams. Time at morning, empty stomach for breakfast. So instead of regular breakfast, two apples were given to the volunteers for 7 days. The apples were purchased from market from one based on one area. So volunteers were told to take same type of normal scheduled diet with no excessive consumption of hot, cold, heavy, light, dry diet, with no junk food, no liquids other than water during the experimental period. So, and the methodology of experiment, number one experiment was assessment of rasa. Then second was assessment of rasa. In vitro and in vivo were done. And for assessment of VPAC, experiment 3 was done and experiment 4 for virya. The experiments were based on the guidelines of Dr. Bavdekar's PhD thesis. He has done PhD on cheese. So cheese Ayurveda is the exploration of the extension of Anukta as a Anukta Dravya. So based on that, we have performed the study, and the for rasa assessment, the protocol was the established protocol designed by Dr. Nishtesh Varsan has taken as a ready-made protocol. So all the observations for the rasa assessment, these are the criteria, that is feeling of unctuousness, feeling of satisfaction, feeling of pleasure, feeling of softness, moistness of tongue, spreading all over the mouth, clear, astringent and dulling effect on tongue, sense of constriction or choking in throat, feeling of stiffness in tongue. These are the regular symptoms of various rasas, shad rasas. So assessment of rasa. Madhura rasa can be assessed for its taratamatva by keeping the juice in petri dish on the floor. So pipilika bhakshan of apple juice in petri dish observed. Yes or no? So if madhura rasa, madhura tama, then pipilika bhakshana we can observe. So for assessment of vipaka, a special questionnaire was designed, that is in that frequency of purisha in a day, quantity of purisha, that is speakers, then easiness of purisha, frequency of mutra in a day, quantity of mutra in general, easiness or difficulty in passing of mutra. Also such type of questions were for the assessment of virya, feeling of suppression of thirst by eating apple rather than water. So feeling of good after consumption of apple and feeling of satisfaction after consumption of apple. Then for virya assessment, one another experiment was conducted, that is one paper fruit will be given to test first and feeling of suppression of burning sensation after consumption of apple fruit. If yes, then the apple might have been Shitavirya. Then apple fruit will was given for external application on hand, suppression of burning after application of apple juice. So with external and internal questionnaire, we assess the virya. So the observations, feeling of unctuousness after consumption of apple, out of 20 20 volunteers were felt unctuousness, that is jivva snigdhata in mouth, while 10 volunteers were not felt unctuousness after consumption of apple, that is lakshan of madhura rasa. Then feeling of satisfaction after consumption. So 28 volunteers were felt satisfaction, while 2 volunteers were not felt satisfaction. This is the lakshan of madhura rasa. Then feeling of pleasure after consumption. So 28 volunteers out of 30 were felt pleasure. Then feeling of softness or moistness. The 29 volunteers were feel moistness of tongue. So all these lakshanas, with all these lakshanas, we can say the taste of apple was madhura, that is sweet. Spreading all over the mouth. 27 volunteers were feel spreading all over the mouth. Then feeling of clear, astringent and dullness effect of tongue. The 7 volunteers feel astringent, while 23 volunteers were not feel. So that is the lakshan of kashaya rasam. So sense of constriction or choking of throat. 4 volunteers were felt that constriction in throat and 27 not felt. So feeling of stiffness in tongue. Only 4 volunteers were felt stiffness. So all these 3 symptoms of that Kashaya rasa. So we can say we will see the later results. The immediately perceived taste after consumption of apple out of 30 volunteers, Madhura rasa perceived as a Pradhana rasa by maximum volunteers, and Amla rasa followed by Madhura rasa perceived, that is of 5 volunteers, and Madhura rasa followed by Kashaya is of 4 volunteers. So out of 30, 2 volunteers were filled cleansing and drying of mouth effect, while 28 were not filled. Then assessment of virya. Out of 30, 27 volunteers were filled suppression of thirst by eating apple rather than water. Then feeling of suppression of burning sensation. 27 volunteers were filled suppression of daha, that is burning, by induced by one pepper seed by eating apple rather than water. So we can say this is the symptom of Shita Viryatma of apple. 27 and Shita Virya assessment externally also 27 volunteers were filled suppressed of daha, that is reduced burning sensation after application of apple juice by induced pepper seed, daha induced by pepper after. So Sevafala of Madanpal is described as Sinchitika by in Charak Samhita or Simbitika in Sushrut Samhita. And one of the Badar Bhed as per the Ashtanga Hruday commentator Hemadri. So it is one of the Panchabadari, the Sevafala or Sinchitika is mentioned. So in assessment of rasa, it was found that 67% volunteers felt unctuousness, 93% that is, felt satisfaction, 90% felt pleasure, softness, spreading all over the mouth, and 70% has immediately perceived madhur rasa after consumption of apple. Above all parameters are all of madhura rasa. So apple is concluded as madhura in rasa. Externally, as more ants were attracted towards apple juice than apple pieces, apple is madhuratama, we can say. Assessment of virya, suppression of thirst was found in 93%. Externally induced daha was found to be suppressed in 90%. Internal induced daha was found to be suppressed in 83% of volunteers. So we can say apple is Shitavirya, of having Shitavirya. In assessment of Vipaka, there was increase in frequency of Mala Pravritti in 53% volunteers and frequency of Mutra Pravritti in 83%. And Purisha Matra, that is quantity of Purisha increased in 86% and quantity of Mutra increased in 90%. So all parameters matches with Madhura Vipaka. So apple, it is found that apple is of having Madhura Vipaka, we can say. This was the discussion or the statistical analysis of the what results we saw. So it was the same. So we will go the next. So on the basis of critical evaluation, Simbitika or Sinchitika Phala is the classical. Sinchitika Phala is the Seva Phala of Madanapalu Nigantu. So Sevafala is proved as apple fruit in this study. After analysis of data and questionnaire, Pradhana rasa of apple is Madhura and Anurasa of apple is Amla and Kashaya. So Madhura is followed by Amla and Kashaya. After the analysis of data and questionnaire, Virya of apple can be considered as Shita and Vipaka as Madhura. Then experimental observation of Sara property of Sevafala is seen instead of Grahya. During this study, Lakshana of Kapha Sanchay was found in 8 volunteers at the end of trial. So we can say it is a property of having Kapha Vruddhikara property. as per the text. So now we will move towards the next research, that is another cultivation related research work. So comparative study of quantitative evaluation of patola, that is Trichosanthus aguina, that is the vegetable patola cultivated by Vrukshayurveda and conventional cultivation practice. So this is a published paper, and the work done by my student Dr. Jagruti Chaudhary with me. So the assessment criteria was the patola cultivation. The another work we will see the soil testing parameters. So pre and post samples of soil was collected and given for testing in renowned institute. Copper, iron, zinc, manganese, phosphorus, alkali, organic carbon, phosphorus, pH, and these micronutrients were tested in the soil. Then germination time, onset of germination, germination rate was calculated. Then germination percentage was calculated. Flowering time, fruiting time, number of flowers, number of fruits, and the yield obtained from all three groups was recorded and compared in terms of number of fruits and average weight of fruit also. So the experiment was conducted in three groups, that is the Patol Trichosanthus aguina soil process. Group A was soil process with tila cultivation. So according to Vrukshayurveda, this is the Vrukshayurveda method group, that is sesame oil, cake water composting 7 days, and tila process soil was the group. Then in group B, tila process soil was used, and instead of sesame oil cake water, cow dung compost was the alteration done in this group. And in the third group was the unprocessed plain soil, that is the conventional method, in which the only cow dung compost was used. So in Trichosanthus aguina cultivation, so the table shows significant rise in the levels of ferrous sulfate, potassium, and zinc in processed soil, whereas the copper, phosphorus, organic carbon, manganese were decreased in the processed soil. pH of both soil samples were alkaline, showing not much difference. And the rate of germination was seen more in A, that is in Vrukshayurveda group, that is 33%, and the group B was in 23%, and in group C it was less. So it is observed that rate of germination of group A were better than in that of group B, followed by group C. Then seed germination rate 10 days as compared to seed group B. So A was better. Group A got early flowering, followed by group B. Then group A showed more number of flower count than that of group B, than group C. Flowering rate of group A plants were observed to be more than group B. Then group A has a better fruiting rate. Other groups showing a rate of 45% than group B. So yield was found to be more in group A as compared to group B and C. So Vrukshayurveda technique was showed the successful proven in this study also. So here the soil analysis, we can say the processed, so in processed soil, ferrous sulfate count was high, and zinc also count was high, and the potassium count was also increased in Vrukshayurveda. So on the basis of observation, group A Vrukshayurveda method for patol cultivation showed maximum results than group B and group C. This result can be due to combined effect of soil processing, seed processing, and use of khalika jala, that is sesame cake water, as compost for group A. Group B, where only soil was processed as per Vrukshayurveda method, also showed better result than conventional method. Thus, it can be concluded that the method given in Vriksha Ayurveda is beneficial for the cultivation of Patol. It indicates that Vriksha Ayurveda can be proved efficient for the cultivation of medicinal plants and maintaining the natural qualities of the plant. This paper is is published. So in that study, one more observation I want to share with all of you. So as per Vriksha Ayurveda, so as per Surapala Vriksha Ayurveda, they were irrigated with Khalika Jala, that is sesame seed cake mixed in water. The spray of bhasma, that is gomay and ishtika churna, was sprinkled on affected parts of climber. So for as a pesticide, the ishtika churna, that is powder, brick powder, and the gomay, that is cow dung powder, was sprinkled. And one another preparation, foliar pesticide we used, a foliar pesticide prepared by using fresh leaves of Agnimantha Sitafala, that is Premna, then Anona, then Arka, that is Calotropis, Azadiracta, and Ipomia, Besharam, that is leaves that Pach Patti Ki Dawa. It is called locally, the name of that foliar pesticide is. With the help of Gomutra, the leaves were collected from institutional herbal garden and nearby field. And with the help of Gomutra, that is cow's urine, the pesticide was made. So procedure was fresh leaves of above mentioned plants were taken in the quantity of 5 gram each and soaked in 3-liter water and 1 liter of Gomutra. This mixture was kept steady for 7 days for decomposition. After 7 days, the mixture was then heated and a decoction was prepared by reducing it to 500 ml. It was then filtered by a cloth and diluted with 1 liter of water. The diluted solution was further sprayed on the climbers. On group C, thiamate or organophosphate was used as insecticide. And about 2 methods for pest control were applicable for both group A and group B, and the results was very much promising results we could see. So the actual study was conducted as the comparative study of qualitative and quantitative evaluation of Patola, that is Trichosanthus cucumerina, cultivated by Vriksha Ayurveda and conventional practice. This and quantitative and qualitative evaluation of 2 species of Patola, as I have mentioned earlier. I have done the market analysis of these 2 species earlier. That is Trichosanthus cucumerina Tikta or Vanya Patola and Trichosanthus agrina, that is Shaka Patola. So in this we can see the seed treatment was given. The selection of seed, sowing of seed was done. So healthy seeds were taken for the study. Then the seed preparation, dry grass ash was prepared by burning. And after cooling the ash, the seeds of patol were rubbed in the ash between both hands in the month of Falguna. So as per Vriksha Ayurveda reference, the seed sowing should be done in the month of Falguna. So the natural period of Trichosanthus cucumerina is the monsoon from July to October. In this study, this variety of patola was cultivated in the month of March, that is in Falguna, and harvested in month of July. A successful growth was seen in the plants of group A, that is in Vriksha Ayurveda, than group C, which was grown conventionally irrespective of its natural season. Soil preparation and soil analysis, fertility of the soil refers to ability of the soil to provide all the required essential nutrients and the water to the plants for their healthy growth. So plants require 16 essential nutrients which are supplied by the soil, out of which nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. All these micronutrients are required relatively in large amounts for the plants, whereas micronutrients like iron, manganese, copper, zinc are required in relatively small quantity. that it is very important to maintain or enhance the fertility of soil. So as per the reference given in Vrukshayurveda, first the soil is said to be processed with tila cultivation, that is sesame seed cultivation, to enhance the fertility of soil. The results of the soil testing showed a significant difference in the mineral content between the two samples of soil. So pre-cultivated soil and the plain soil and the post-cultivated soil, and with the soil analysis, we can see the clear-cut difference. With the processed soil, where tila cultivated soil showed more increased values of minerals. So sesame seeds contains minerals like calcium, iron, magnesium, phosphorus, potassium, sodium, and zinc. This clearly indicates the effect of tila cultivation on the soil. So seed processing and germination as per reference has given such treatment. The seeds of Trichosanthus cucumerina sprouted early in case of group A, that is in Vrukshayurveda group, even more in number than other group. So this might be due to effect of these seeds processing on the seeds of group A. Some of the seeds of group B, C were found become hollow, brittle easily, and broke, spoiled sowing. So those spoiled seeds were replaced with the healthy ones, whereas the processed seed of group A were unaffected and was found to be healthy till the time of sowing. So straw or dry grass ash is characterized by an alkaline pH as well as by a mineral content of potassium, calcium, phosphorus, magnesium. Ash from straw also contains micro elements applied in plant fertilization. They are of iron, manganese, zinc, copper, etc. So ash was also used in ancient days for the preservation of seeds. It is known to be very effective in keeping all the pests and insects away from the stored seeds. It absorbs the moisture content and prevents the seed from getting spoiled due to the moisture, making it the best way of preservation of seeds for a very long time. Thus, all these factors may have helped the seeds of group A to sprout well and grow well, flowering, fruiting yield. The results seen in group A, that is in Vrukshayurveda method, may be as a result of processed soil and sesame cake water, which was used as a compost for group A. Sesame seeds are a good source of minerals like calcium, iron, magnesium, phosphorus, potassium, zinc. These are among the essential minerals of the plants required for a proper growth. Since sesame cake was used in the form of compost with water medium, it may have facilitated the uptake of nutrients by the plants. Also, sesame cake is an organic fertilizer useful for the plants. So the process of soil of group A, that is tila cultivated soil, was found to be rich in potassium. Potassium of plant, being one of the essential nutrients for the plants, promotes flowering and fruiting in the plant. The final yield of fruits were observed to be good both in terms of fruit count and weight. This can be due to the effect of compost used and also the processed soil. So I will move towards only the conclusion point of view. See, here are all the photos of that experiment. Then HPTLC also done. Then group A sample has good separation of phytoconstituents, that is in Vrukshayurveda group found to be more effective. Group A sample has comparatively larger peak and approximate proportion of constituents also was more in group A. And germination rate, flowering, fruiting rate, comparatively good cultivation observed in Vrukshayurveda method than conventional. And HPTLC fingerprinting showed a positive significant results in plant samples cultivated by Vrukshayurveda. So here the Vrukshayurveda and the confirmation also, the cucurbitine and cucurbitine E and cucurbitine B in the Vrukshayurveda group, we can see the more. So quantitative and qualitative analysis has also had done. Then the next study was done, comparative study of genuine and market samples of Trivrut root on the basis of pharmacognosy. here also the observation filed that all the samples were comparable. Adulteration was not found, and most of them, some differences we can say. So in the field sample match the Aruna Nishottar as per Charaka, that is Operculina terpethum, botanically, which is easily available in the market and commonly used for Sukha Virechan or Nitya Virechan. That is the Aruna Nishottar of Charaka. And Krishna Nishottar variety of Trivruta is Tikshna Virechan, was not found in Maharashtra 4 market sample, which is of Ipomia petaloids, which is not found in this study in the market. So there are the market samples. So field and market comparative study was done. Then another study was the classical Badar, Jujuba varieties, different varieties and their comparative study. This study was also, these are the various field and field samples collected, Badar varieties. Then literary study, two literary study completed. So one literary study is the in context of Dravyaguna, that is Ratna Prabha commentary of Nishalkara on Chakradatta. So it is unpublished, or right now it is not out of print. So with this literary work, new research areas opened. That is changing trends of drugs periodically in Ayurveda. So this is also very much very useful. Clinical findings were found in this one, but we will move to the next. And now we will see some ongoing research work. There is one another literary study of the two commentators of Deepika and Gudhartha Deepika commentary of Sharangdar Savita is going on with my student Dr. Rasma Inanda. And one more, another Shiva Kosha, one literature, one lexicon of Dravyaguna, which is almost unexplored. So with the help of, on the best of that Shiva Kosha, Prachin Amalaka, study of Prachin Amalaka work is going on. So exploration of morphological characters of plants based on Shiva Datta Tika and experimental Rasa Pariksha of two source plants of textual Prachin Amalaka is ongoing. So with that, with these few examples, I am concluding my work, and I am very much thankful to Dr. Asavari and her team for giving me this opportunity to present my work in front of you, and for giving me such a good global platform to me for my work. Thank you, Asavari.
Thank you so much, Dr. Ila. It was absolutely amazing. You have done such an extensive work, so many years, and we are so fortunate to hear and see all of those results and all the experiments that you have done during this, long span. And it was absolutely wonderful to hear you. I'm so glad, and I'm also like very proud being the alumni of CARC, and I see you have done such an extensive work there, and you are a part of it. I mean, it's so lovely to meet you again. And there were so many interesting things that you shared. I feel like here in the West, in the US, we have so many different fruits, which is really hard to find, like its effect in terms of Rasavira Vipak and Karma, and explain all of those things in terms of Ayurvedic language. For example, peaches or nectarines, like those things are very easily available. If you look at various herbs, which are Western herbs, like rosemary, oregano, sage, so it is difficult to understand exactly how do they work in the body. So the experiment that you showed and explained in terms of apple and how it was conducted, it would be really beneficial actually for all the listeners to experiment and a little bit understand how we can understand all of these herbs and fruits which are available here. So all the Anukta Dravyas and how to figure out their effect. That was absolutely amazing.
Thank you. And since year by year now, I am also improving with the effect of the previous ones. We are improving for how to conduct a research with minimum bias. So we have to think for that also. So all these were, we can say, very primitive studies, we can say, and we can conduct it on the larger, in large quantity or on large volunteer uh, count. So it will be very beneficial, and the results were also very promising.
Absolutely fabulous. Thank you so much for sharing all of this with us. And for
Thank
all our
you.
attendees, thank you so much for attending our webinar. And please watch and subscribe to our CAR YouTube channel. We will be uploading this webinar on our CAR web YouTube channel. So once again, I invite you all to become a member of CAR to learn about different activities and also listen to various webinars, previous as well as the upcoming webinars. I welcome all of you. Thank you so much.
Thank you.
Thank you, Dr. Ila.
Thank you.